A city left behind. The day a nuclear power plant exploded. On April 26, 1986, the Soviet Union, the country that included what is now Ukraine, a nuclear power plant called Chernobyl, had a terrible accident. A reactor, the machine that spits atoms to make electricity, overheated and exploded. The blast was so powerful that it sent radioactive material high into the sky. A city 3 kilometers away had to be evacuated. 50,000 people left their homes, their pets, their entire lives, and most of them never came back. Today, the city still looks like a ghost town, but here's the surprising truth. The accident didn't have to happen, and more surprisingly still, the nuclear power is actually much safer than many people think. How did Chernobyl explode? A flawed design and a flawed test. The reactor at Chernobyl was built in the 1970s. Modern nuclear reactors have safety systems, automatic shutdown switches, cooling pumps that turn on when temperatures rise, backup power, and a thick concrete shell around the reactor to contain any explosion. But Chernobyl's reactor had 2 serious problems. First, it had no outer containment shell. Second, and this is the part that was kept secret, it had a dangerous design flaw. At low power, the reactor became unstable. The lower the power, the harder it was to control. The engineers running the plant did not know about this flaw. During a routine safety test, the engineers reduced the reactor's power to a low level, as their test instructions allowed. What happened next was catastrophic. The reactor's power suddenly surged. Without knowing the instability flaw, the engineers could not react in time. In minutes, the reactor core overheated, the water inside turned to steam, and the pressure explosion blew the reactor open. Radioactive material flooded into the air. The key lesson? Chernobyl happened because of 2 things together: a reactor with a hidden design flaw and a test carried out without knowing that flaw exists. Fukushima, when nature overpowers protection. In 2011, a massive earthquake struck Japan. It was one of the strongest earthquakes ever recorded. The shaking knocked out electricity to 3 nuclear plants at a plant called Fukushima. Without electricity, the cooling pumps could not run. Without cooling, the reactor core started to overheat. The plant had backup power, diesel generators. But the earthquake triggered a tsunami, a giant wave that followed the shaking. The tsunami was so enormous that it flooded the entire plant, destroying the backup generators. In hours, all cooling was gone. 3 reactors melted down. The cores became so hot that they melted through the bottom of their containers and leaked radioactive material. The consequence was enormous displacement. Over 150,000 people were evacuated. Estimates suggest over 2,000, mostly elderly and seriously ill, died from the stress and disruption of being forcibly relocated, not from radiation itself. One key difference from Chernobyl: the containment buildings held. The outer concrete shells did their job and prevented an even worse catastrophe. Modern reactors, built to fail safe. The reactors built today are all fundamentally different from Chernobyl's or Fukushima's old designs. They use something called passive safety. That means if everything fails, all the pumps, all the electricity, all the human operators, the reactor will automatically cool itself. No electricity needed, no human action needed. Physics does the work. How does this work? In modern reactors, cold water sits in a pool above the reactor. If the reactor overheats, a plug automatically melts away. Not from computer command, but from the heat itself. The cold water falls down and cools the hot core. No pumps, no wires, just gravity and the laws of physics. It's like a building that automatically puts out its own fire, even if no one is home. Modern reactors also have defense in depth, multiple layers of backup. If cooling system A fails, system B kicks in. If B fails, system C starts. There's no single failure point. It's the difference between a car with only one brake and a car with 4 independent brake systems. If one fails, 3 others are still working. The truth about nuclear safety. Here's a fact that surprises most people. Nuclear power causes fewer deaths than per unit of energy than coal, oil, or natural gas. Coal pollution kills over 800,000 people around the world every year, not from dramatic explosions, but from air pollution. Coal smoke contains toxic chemicals that damage lungs, hearts, and brains. The deaths happen slowly, invisibly, every single day. Nuclear power has caused fewer than 1,000 confirmed direct deaths in over 70 years of global operation, including Chernobyl, Fukushima, and mining accidents combined. That works out to roughly 10 to 15 deaths per year on average, spread across 400 reactors worldwide. The dramatic accidents are rare, but when they happen, we remember them because they are visible. Catastrophic aren't scary. Cold deaths are invisible, so we don't think about them. Nuclear accidents are visible, so they feel dangerous even when they are statistically safer. So, is nuclear power safe? The answer is, it depends what you mean by safe. Risk and danger are not the same thing. A nuclear accident is low probability but high consequence. Accidents are rare, only 2 at the highest severity level in over 70 years of global nuclear power, Chernobyl and Fukushima. But when one happens, the damage is catastrophic and visible. Coal pollution is high probability but invisible consequences. Every day thousands of coal plants are burning. Every day thousands die, but slowly, invisibly, from diseases no one traces back to coal. Today, 70 years after the first nuclear reactor, modern reactor designs are much safer than Chernobyl or Fukushima. They have passive safety, defensive depth, and automatic shutdown. An identical earthquake hitting a modern reactor would not cause a meltdown. In the next episode, we'll tackle an even harder question. What do we do with the radioactive waste that nuclear power plants create? And is it true that nuclear fusion will solve everything?